A powerful cosmic event, officially labeled FRB 2025-0316A and nicknamed RB Float, short for Radio Brightest Flash of All Time, was recently detected in the outer edges of the nearby spiral galaxy NGC 4141. This burst is part of a rare and puzzling group of phenomena known as fast radio bursts, or FRBs. Extremely brief but incredibly bright flashes of radio waves, often coming from far beyond our galaxy. The first FRB was actually found in older telescope data in 2007, although the event itself happened around 6 years earlier during a survey of pulsars in the Magellanic Clouds. These radio bursts last just a few milliseconds but carry an enormous amount of energy, as much in one split second as our sun produces over 10,000 years. Scientists still don't know exactly what causes them. Some possibilities include highly magnetic neutron stars near supermassive black holes, or more speculatively, signals that resemble advanced alien technology. The FRB discovered on March 16, 2025, came from NGC 4141, a barred spiral galaxy roughly 130 million light-years away in the constellation Ursa Major. It was detected using CHIME outriggers, a Canadian radio telescope system that was recently upgraded to pinpoint the exact origin of FRBs with much greater accuracy. With the upgraded CHIME system, we can now trace these short-lived radio signals not just to a galaxy, but even to specific regions within that galaxy, said Dr. Amanda Cook, a postdoctoral researcher at McGill University. After spotting the FRB, her team used the James Webb Space Telescope to check the same location for any signs of infrared light, something no one had done before with an FRB. This was a rare chance to get Webb to observe an FRB site right after it happened, said Dr. Peter Blanchard from the Harvard and Smithsonian Center for Astrophysics. And we found something, a faint source of infrared light very close to where the radio burst came from. The object, now called NIR-1, appears to be either a red giant, an aging expanded sun-like star, or a massive star in its midlife. Although these types of stars aren't expected to directly cause FRBs, they could be part of a binary system where an invisible companion, like a neutron star, is stealing material from the larger star. This process might trigger the kind of activity that produces an FRB. Because this FRB occurred relatively nearby and its location is so well defined, the Webb telescope was able to take incredibly sharp images of the surrounding stars, the clearest view ever captured around an FRB source. There have been many theories about what causes FRBs, but until now, we didn't have enough data to really test them, said Professor Ido Berger, also from the Center for Astrophysics. Now, being able to see the individual stars near an FRB is a major breakthrough. It gives us clues about what kinds of environments might be producing them. That said, the star detected near the FRB may not actually be related to it. So the researchers looked at the broader surroundings and found a small cluster of young, massive stars nearby. Based on this, they suggested that a massive star in that cluster might have already died and turned into a magnetar, a type of supermagnetic neutron star, which could have emitted the FRB. Since magnetars are very faint, it wouldn't show up in the Webb images. The team also explored other ideas, like the burst coming from an object in a dense group of old stars, or a massive giant star, but these objects would be much brighter than what was seen, so they ruled those out. Even if the nearby star isn't the source, we've still gained a lot of insight into where this burst came from, said Dr. Blanchard. If it wasn't from a two-star system, then the evidence points to an isolated magnetar as the cause. Another theory is that the infrared light they saw wasn't from a star at all, but a reflection or echo of the burst itself, possibly from a flare given off by the magnetar. If that's true, the light should fade over time, and the team plans to use Webb again to check if that happens. This is just the beginning of a new way to investigate FRBs, said Professor Berger. With Webb's sharp vision, we can zoom in on the exact spots where these mysterious signals are coming from. Since we never know when the next FRB will pop up, we have to be ready to act fast.